All right, today we're going to take a look at the elimination method for solving linear systems. Yesterday we took a look at just kind of the basic form of the elimination method where we could add the like terms together by combining the two equations. And when we did that, one of the variables would eliminate, which allowed us to solve the system. Now, if we look at this system here, if we were to add the like terms together, basically adding the two equations to make one equation, which variable would eliminate? Maybe you noticed. None of them. So if I add the x terms together, so 3x plus 7x, if I add the y terms together and the constant terms together, I would get the equation, let's see, 7x, 3 plus 4 is 7. Let's see, 1y plus negative 2y is negative 1y, and 20 plus negative 20 is 0. So actually, it wasn't any of the variables that eliminated. It was more the constant terms that added to 0. So there weren't actually any eliminations that occurred there with the variables. So right now, this system is not ready for elimination. Now, what it means, or what it doesn't mean, is that you can't use elimination. It just means we have to do something first. So there's a little trick we can use in algebra, and we can actually multiply any equation by a factor. Okay, any number that we want. We can multiply everything in the equation by that number, and it creates what's called an equivalent equation. So here what I'm going to do is just multiply each equation by a factor of 3 to create an equivalent equation. And the equivalent equation would have the same solutions as the original equation, basically making it the same thing. It just has bigger numbers in it. So in this case, I can multiply everything by 3. Now when my equation is set up the way it is in standard form, I basically multiply all three parts by 3. So 2x multiplied by 3 would become 6x. The minus 4y times 3 would become minus 12y. And then the negative 7 times 3 would become negative 21. So this original equation, 2x minus 4y equals negative 7, has the exact same solutions as 6x minus 12y equals 21. Okay, even though the numbers are bigger in that equation, the x and the y values that would make the equation true are the same. So I'm going to do the same thing to the other equation, just so you have another example. And I could have multiplied by anything other than 3. I'm just using 3 as an example. So if I multiply the second equation times 3, I would get, let's see, negative 12x, since negative 4x times 3 is negative 12x. Y times 3, remember that's like a 1y times 3, is positive 3y. And then 6 times 3 is 18. So the equation I started with and the equation I ended with are what we would call equivalent equations. Now, if we go back to our systems, well, let's just focus on one at a time here. If we look at this first system with these two equations, right now nothing would eliminate. Because if I look at my x's, they would not add up to 0. My y's wouldn't add up to 0 either. However, I do notice that I have, with my y terms, I have one positive and one negative term already. Remember yesterday we said we want these to be opposite so they add up to 0. And I also notice if I were to be able to make this a positive 7y somehow, I would then have a negative 7y and a positive 7y that would add up to 0 or cancel out. So what I could do here, a little trick is, I could multiply this first equation times 7. Everything in the first equation times 7. So 5x times 7 would become 35x. The 1y times 7 would become 7y. And then the 9 times 7 would become 63. I have to make sure I multiply everything by 7 in that first equation. Now with the second equation, I'm going to go ahead and just bring that down. And I don't know why that little box showed up. Can I get rid of that? There we go. And now when I look at my system, it is all set up for elimination. So if we think back to what we did yesterday or the previous lesson, I can now add my like terms together. So 35x plus 10x would be 45x. 7y plus negative 7y would be 0. It would 0 out. And then 63 plus negative 18 would be, let's see, 45. And then when I divide that out, I would get x equals 1. Okay, and then remember, you have to go back and plug that in and try to solve for y and figure out what y equals. But that's that first step. That's how we can use elimination, is we can actually change an equation if it's going to help us eliminate one of the variables. Okay, so it's kind of a little puzzle game. You have to think ahead to try to figure out what you're going to need so that you have opposite coefficients so that those terms add up to 0. Now, if we're to look at another one, let me create some space here to get rid of this. If we look at example B, we have, let's see, negative 4x plus, and then 1x in the other equation. Now, I notice that if I already have negative 4x in the top equation, I could get the bottom equation to be positive 4x pretty easily. I just have to multiply that by 4. So let's do that. Let's multiply everything by 4 in the bottom equation this time. Okay, so we're going to do 4 times x, 4 times 3y, and 4 times negative 6. Just remember, you have to multiply everything in that equation by 4, not just one part or two parts, but all the parts. So we have 4 times x is 4x, minus 4 times 3y, which is 12y, equals 4 times negative 6, which is negative 24. Now that top equation, I'm just going to leave that the way it was. I'm just going to make sure I have things lined up vertically so everything's aligned. And now when I add my two equations together, I have negative 4x plus 4x, which adds up to 0. There's my elimination that happened. It wouldn't have happened the way it was originally written over here because I didn't have opposite coefficients. If I go back to my revised equations, I can continue solving. 9y plus negative 12y would be negative 3y. And let's see, 9 plus negative 24, or 9 minus 24 is negative 15. So then we divide that out, divide by negative 3 on each side, we get y equals 5. Okay, and again, then we go back and solve for x. Okay, we'd have to do that last step, substitute and solve for x into one of those original equations. But at least we were able to get the elimination to happen because of what we did right there. We multiplied the bottom equation by 4. And we actually could have multiplied the bottom equation by 3, because did anybody notice that 9 is a multiple of 3? So we already had 9y in the top equation, and we could have pretty easily multiplied the bottom equation times 3 instead to get a negative 9y in the bottom equation. Okay, that would have worked too. Now, let's see how this works with a full example. I would encourage you to copy this down in your notes, because it will be helpful as we get into any practice problems. So as we look at our two equations here, our system, I notice that with my x's, I don't really have multiples of each other, right? 4 is not a multiple of 3, at least for the x's. When I look at the y's, I do notice that I have multiples there. I have negative 2y in the bottom equation. So if I leave that the same, so 4x minus 2y equals negative 20, I would want the top equation to change so that I have a positive 2y in that spot. Okay, because then I'm going to be able to cancel those out, since 2y plus negative 2y is 0. So I have to think about what is actually going to get me that positive 2y. Right now it's positive 1y. What would I have to multiply that by to get positive 2y? Well, hopefully instead you would have to multiply everything times 2. Now if I multiply everything by 2, so 3x times 2 would become 6x. Y times 2 becomes 2y, which we wanted. And on the other side of the equal sign, 20 times 2 becomes 40. So here's my system. Let's see what happens when I add the like terms together. 6x plus 4x is 10x. 2y plus negative 2y is 0. There's my elimination. And then 40 minus 20 is 20. So if 10x equals 20, I divide by 10 on both sides. X would have to equal 2. And that's not my final answer, but it is the first part of my answer. X equals 2. So now we have to do our substitute and solve as our last steps. So I pick an equation, either one of the original equations, and if I know my x value, I'm trying to solve for the y value. I think actually the first equation will work out better for us here. 3x plus y equals 20. That was the original equation. And we now know that x has a value of 2, because we just solved for that, right? That was what we just discovered over here. So if x is 2, I can replace it. I can change it. I can substitute it. And now that gives me another piece of the puzzle that I can use to solve this equation. So if 6 plus y equals 20, I subtract 6 on both sides, and y would have to be 14. So my final solution is when I put those two together, the x value first, the y value second. Let's take a look at another example. Okay, I want you to just take a moment to think about what could you multiply one of the equations by so that elimination would work. Now, there may be more than one correct answer to this, but I think the best answer is to try to get the x's to eliminate. Because 6 is a multiple of 3, it will be easier to do that. If I wanted to get the y's to eliminate, I'd have a little bit more work to do. 9 is not a multiple of 2. Okay, so while I have 9y in the first equation, it would be pretty difficult to try to make that bottom equation be negative 9y. What I would have to do is like multiply it by 4.5. And I don't really want to multiply everything in that equation by 4.5 because it's going to create decimals in other places, or fractions even in other places. So I don't want to do that. So instead I focus on the x's because my coefficients are multiples of the other coefficient. My first equation has the larger coefficient, so 6x. So I'm going to leave that first equation the same. 6x plus 9y equals 24. It's my bottom equation that I want to change. I want the bottom equation to actually start with negative 6x so that I have the elimination there. 6x plus negative 6x would zero out or eliminate. So what do I have to multiply by to make that become a negative 6x? Well, it's already negative, but I need the 3x to become 6x. So I would need to double it. I want to multiply that by 2. And I have to remember to multiply everything times 2. Okay, so 2 times negative 3x is the negative 6x that I wanted. 2 times negative 2y is negative 4y. And then 2 times negative 37 is negative 34. Now I have the elimination ready. Okay, I add my like terms, so I add everything straight down. 6x plus negative 6x eliminates to 0. 9y plus negative 4y is 5y. And 24 plus negative 34 is negative 10. Now when I divide that up, I'll get my answer. Y would equal negative 2. Not my final answer, but it is part of it. I know the y value. Now I want to go back and try to figure out the x value. So to do that, I'm going to use my first equation up there because it was all positive numbers, all positive coefficients. I just think it makes it a little bit easier to work with. And I can substitute what I know. Okay, so I knew that the y value was negative 2. So I have to keep in mind I'm taking y out of the equation and replacing it with negative 2. Okay, it's important that you put the negative 2 in for y and not like over here by the x. We don't know what x is. I can't change x right now. All right, so we keep solving. 9 times negative 2 is negative 18, so I'm just going to write it as minus 18. And we keep going. Add 18 on each side. And 24 and 18 would add up to 42. So divide, x would equal 7. So those are the parts of my answer. My final solution is when I write it as an ordered pair. 7, comma, negative 2. There's our solution using elimination with the multiplication method.